Okay, yesterday's lesson we talked about probability distributions for discrete variables. Today we're going to talk about probability distributions for continuous variables, and the most widely used one is that called the normal distribution. So, characteristics of the normal distribution is, first off, the graph of the curve is bell-shaped, and that of course means it's going to also be symmetric with respect to the mean. The mean, median, and mode are equal and located at the center. The curve is continuous. It approaches but never touches the x-axis, and the total area under the curve is equal to 1, or 1, of course, is equal to 100%. So whether you give me a decimal or a percentage does not matter. But one thing to keep in mind, if you think about a continuous probability distribution for a 400-meter run, okay? I have some pictures here just to kind of help you understand it a little bit better. But this first one, if I sampled 100 athletes and I created a histogram, it might look something like this. And if I widened my sample to 1,000 athletes and made my bandwidth smaller, then you can see that the curve looks even more symmetrical. If I widened it yet again, and if I continue to widen it for our total population, this is where we get that curve that we refer to as the bell curve, the normal distribution. Okay, and we have something called the empirical rule that describes this normal distribution. Okay, and what it is, the mean is at the middle. Okay, remember that's the mean, median, and the mode, and it's symmetric. So what we know, and part of how the standard deviation is defined, is that on both sides 34% fall within one standard deviation. So that means a total of 68% is within one standard deviation between these two lines. And then we have 95% between, if we go out another standard deviation, so that would be going out that far. And then the last one would be going out 3, and that would be 99.7%, which is why they refer to this sometimes as, this empirical rule is also referred to as the 68, 95, 99.7. Okay, so that again says that approximately 68% of your data falls between plus or minus one standard deviation. Okay, 95%, approximately 95% of your data will fall between the mean plus or minus two standard deviations. And again, 99.7% of the data will fall within plus or minus three standard deviations. So how are we going to use this rule? We have a machine used to fill water bottles. A machine used to fill water bottles dispenses slightly different amounts into each bottle. Suppose the volume of the water in 120 bottles is normally distributed with a mean of 1.1 liters and a standard deviation of 0.02 liters. Approximately how many bottles of water are filled with less than 1.06 liters? So I like to look at the picture. So if we sketch our normal curve, the middle is your mean, and so our mean is 1.1 liters, okay? And then we know that if I go out one standard deviation of 0.02, then I'm going to add it. So 0.02 to plus 1.1 is of course 1.12. If I subtract it, I'm at 1.08. Then if I go out another standard deviation, and my curve didn't look so hot, y'all can bear with me there. Another standard deviation, I would add 0.02 again and get to 1.14. And on this side, I would be at 1.06. And this question says, how many water bottles are filled with less than 1.06? So they're asking me, how many water bottles are in that section right there? Well, from our empirical rule and what we just talked about, that represents 0.0235 of our data. So if I have 120 bottles, then I'm going to do 120 times 0.0235. This is part A. And when I multiply that out, I'm going to get 2.82, and we would round that to 3 bottles. All right. And the second part says what percent of the bottles have between 1.08 and 1.14. So that means they're asking us for what is between 1.08 and 1.14. So remember this is 0.34, 0.34, and this is 0.135. So I'm going to add those up. 0.34, 0.34, 0.135, and we're going to get 0.815. And you can leave it like that, or you can answer 81.5%. Either one is acceptable. Okay? Now, the empirical rule is great if they're asking you for values that are the actual 1 or 2 or 3 standard deviations from your mean, but a lot of times they want to know about numbers that are not those specific values that go with our means. And for that reason, we have to do something called standardizing. Okay? And that method of standardizing gives us a z-value, also known as a z-score or a z-test statistics. And what it represents, it basically takes your data value and tells you the number of standard deviations that a given data value is from your mean. Okay? And so that formula is z equals your data value x minus your mean divided by your standard deviation. Okay? So if I had a mean of 40, a standard deviation of 6, then they could calculate 57.5 by with the mean. Well, this is my x value, so this is 57.5 minus 40 divided by 0.6 gives you 2.92. Okay, and that tells you that 57.5 falls right there in our distribution. 2.92 is 2.92 standard deviations away from our mean. Okay? Keep in mind if your number is negative, that lets you know that you're going to be below your mean. Positive is going to be above your mean. And again, we use these numbers to represent position. Okay? So let's do a few examples with this. Okay, so some examples finding z values. They ask us to find z if our data value is 32, our mean is 28, and our standard deviation is 1.7. So our formula that we just had tells us that the z value is x minus mu over sigma. So that means I'm going to have 32 minus 28 over 1.7. Punch that in your calculator and you will have a z value of 2.35. Okay. Of course, sometimes they want to know what x value gives you that z value. So this time they gave us the z value of 2.15. So I'm going to set that equal to x minus the mean of 39 over the standard deviation of 0.4. So we would, of course, multiply both sides by 0.4, and then we would add 39. So x is going to be 39.86. Okay? I multiplied by 0.4, 2.15 times zero point 0.4, and then I added 39 to find out what my x value is. Now, keep in mind that there are an infinitely many normal probability distributions, all of which can be related to the standard normal distribution. the characteristics of the standard normal distribution, okay? Because all those other ones are going to have different mean values, but the standard one, okay, is going to have, we'll talk about the characteristics and you'll see it up in the curve. The total area under the curve is still equal to 1 or 100%, okay? Almost all of the area is between z values of -3 to 3. The distribution is still symmetric as we had before. The mean now is 0 and the standard deviation is 1. And the curve approaches again but never touches the x-axis. Okay, so we have the same percentages that we did before, but let's see how we're going to use that in a problem. Okay, so the average number of points that a basketball team scored during a single season was 63 with a standard deviation of 18. If there were 15 games during the season, find the percentage of games in which the team scored more than 70 points. So this time I am looking for a percentage, okay, in which the team scored more than 70 points. Assume the number of points is normally distributed. So again, I like the visuals, so I'm going to sketch, bad sketch, but I'm good with that. I'm going to sketch and know that my mean, all right, the average is 63. The standard deviation is 15. So 63 plus 15 is 81. 63 minus 15 is 45. So they're asking me what percent of the games that they score more than 70 points. So 70 is somewhere in here, okay? And of course that means I got to get a z value for that to find out how many standard deviations, because we know this is one standard deviation in both directions, okay? So my z value is going to be that number 70 minus 63 over standard deviation of 18. And that gives me, now, that gives me a z value of 0.39. Now, you have two ways to figure out this problem, but let's go with this first of all. Remember that on a normal distribution, this is 1, this is 0, and this is 1 standard deviation. So 0.39 is somewhere in here. Such it's about right there. Okay, this is where my 70 marker is. Okay, and to find the probability, this is a z value. Okay, so you have something called a z table, z chart, and I'm going to show you how to use it with this problem, and then we're going to talk about how to do it on a calculator, so that if you don't have it, you can do it either way. But on a z chart, z table, these outside, these are giving you the columns, these are giving you the rows, those are your z values. So if my z value was 0.39, then I'm going to go to 0.3 all the way over to 0.09, excuse me. Okay, so in this particular problem, the z value corresponds to a probability of 0.6517. So that tells you that from here all the way to there is 0.6517. Okay, so they're asking us then this problem, what percentage was more than 70 points? Okay, obviously this represents that's less than 70 points, so you would subtract this number from 1, and 1 minus that number is going to give us a percentage of approximately 35%. So that's what your answer will be. Now, I have directions, steps for TI-84 calculator. If you're on the 84 calculator, you turn it on. You're going to hit second. You're going to hit distribution, which is above your variables key. And then you're going to either hit the number 2 or you scroll down and hit enter. It will ask you for the lower bound. Okay, the lower bound, when you work these problems, if you're going all the way to the end, is going to be -4 because that's what we don't want to stop at 3. We're going to go all the way to -4. So you type in -4, your upper bound, excuse me, type in your lower bound of -4, hit enter, type in your upper bound, which is 0.39, and then hit enter 5 times. And the calculator gave you a rounded number of 0.6517. Okay, again, subtract from 1 and you'll get 35%. All right, on the TI Inspire, okay, you're going to hit menu, number 5 for probability, number 5 for distributions, number 2 for normal CDF. And when you hit that, the table is going to come up, and your lower bound again is going to be -4. You're going to hit the tab key to go to your upper bound to hit 0.39. And then you're going to tab 3 times to the OK button and hit enter. And it spit out the number of 0.6517 for you. Okay, so you might want to keep those directions handy. And as we continue to the next problem. Okay, with this next example, we're going backwards. Okay, this time they're giving us the percentage, and we're going to go find the z-values. So again, I'll show you how to do it on your table, and then I will show you, give you the steps for doing it on a calculator. And then from then on, you can choose whichever one you want. On the day of the test, I will give you the z-chart if you do not know how to use your calculator to do it, or do not have one that can do it. Okay, so find the interval of z-values associated with each area. Okay, so we're looking for the middle 25% of our data. Okay, again, I like to draw it, so I'm going to do a really bad sketch of a normal curve. And remember that what's in the middle, my mean is 0. And if I'm looking for the middle 25%, then that means that I want 0.125 on both sides, right? Because that together gives me the middle 25% of my data. Okay, excuse me. So in my chart, that means that from here, because the chart's always given us this number, okay? So if this is 0.125, then from here to that point is, hopefully you realize, going to be, because remember this is just half of it. So what I would do would be 0.5 minus 0.125, which of course is 0.375. So that means that this represents 0.375, and I'm going to go find that number on my z-chart. But remember, it's the probability, and I'm looking for the z-value. Something else before we go there, this is on the left side of the mean, okay? So it's actually a negative in my chart. So on your z-values, your z-chart, I'm looking for, actually, take that back. The answer is going to be negative. This is a probability. This is not what I was trying to get at. Is the answer down here is going to be a negative number because it will be less than 0. We are looking for 0.375, but knowing that it's negative means you're not going to find it up here on the chart where all the numbers are positive. Your z-value is going to be negative. Where are my negative z-values? They're up here. I'm looking in this chart for 0.375. Okay, so you can see now you've got 0.3783 and 0.3745. This one is closer to 0.375. So the z-value that corresponds is going to be negative -0.3. And which column is this? 0.2. So it's going to be a z-value of -0.32. And of course it's symmetric, so it will be the same on this side. So the answer to the question, the interval of z-values is going to be z between -0.32 and +0.32. Okay? Now, let's talk about how we would do that with a calculator instead of the table. So on your excuse me, we'll start with the 84. Okay? You hit the second button, you hit distribute, which is above the variables, and this time you're going to hit the number 3 for inverse normal because we're doing the opposite, and they want the area, okay? And the area in this problem was 0.375. So I'm going to put 0.375, and then I'm going to hit enter 5 times, and it gives me a number that rounds to negative 0.32. Okay, for my Inspire people, we're going to hit menu. You hit 5 for probability, 5 for distributions, 3 for inverse normal. Again, it asks you for the area, 0.375, and we hit the tab, excuse me, 3 times to get to our enter button, and then hit enter, and again, it brings the same decimal that would round to negative 0.32. So we're good. All right. So in the future, I will not go back to the table. I will just push the buttons in the calculator. If you have any questions more about reading the table or needing practice, then please come see me. Okay, so let's talk about the outside 60%. All right, again, I'm going to draw my picture, bad sketch of the normal curve, and 0 is my mean. I want the outside 60%. Okay, so that means that this, hopefully you can realize, remember we got to be symmetric. So if it's the outside 60, then this is going to be 0.3, and this is going to be 0.3. So on our calculator, we're going to put in 0.3 for our area this time, and it's going to give us a number of negative 0.52. And of course, that makes this one 0.52. Now, keep in mind, they're asking us for the outside 60%. Okay, back over here, they asked us for the middle 25%. So I had my expression like this. When I write my answer over here, I'm going to say that my z values, okay, have to be less than negative 0.52, or they have to be greater than 0.52. So you got to be careful about what the question's asking. All right, on to the last thing that we have to talk about. Okay, so remember that the area under that normal curve is referring to that normal distribution is referring to our probability. So we're going to continue with some more problems that somewhat deal with some intervals also. This next problem, the scores on standardized tests are normally distributed with a mean of 72 and a standard deviation of 11. Find each probability and use a graphing calculator to sketch the corresponding area under the curve. So in this problem, the data value, the x, is less than 89. So if we're talking about our normally distributed, okay, then I want to find the z value that corresponds with 89. So z is equal to that value of 89 minus the mean divided by the standard deviation. So put that in your calculator, you're going to get 1.54 repeating. So if you're looking on the table, you would look for 1.55. So my bad sketch of the normal curve. All right, so what you have, remember this is 0, and then we go 1, 2, -1, -2, standard deviations, okay? And if this is 1 and this is 2, then that value of 1.55 is going to be, somewhere here. Okay, that's what's going to correspond to the 1.55. That's my z value. So what I have to go find and what they're asking me for is what is the probability, which is going to be the same as that area, underneath the normal curve. So I'm going to go in when we're looking for this in your calculator, and that was our first set of directions. So on your calculator, you're going to use the number 2 button, which was normal CDF, and punch that in your calculator. So it's going to be second on an 84. Second, distribute. Number two, they're asking you for the lower bound. Okay, remember your lower bound is -4, and your upper bound is going to be 1.55. And when you put that in there and hit your enter key 5 times, it's going to spit back at you the number 0.9393. So to answer the question, it's going to be 93.9%. Okay. Part B says I want to find the values in between two of these. So in this case, I've got to convert each of these to a z-value. So 65 minus 72 over 11 is negative 0.63 repeating. So on that z chart, if you're using the chart, would be negative 0.64. Okay. Um, and then we have um, the other one is going to be 85 minus 72 over 11, and that's going to be 1.18 repeating. And so on your z chart, that of course would be just 1.18. Okay, so looking at our curve, all right, remember those are my z values. Really bad looking curve that time. There's my 0, 1, 2, -1, -2. All right, and so negative 0.64 is going to be somewhere about halfway, right? So this is this point right here. No, that's not, did not get that. Let's try again. There we go, that's better. Negative 0.64. And then 1.18 is going to come right after 1, so that's going to be this point right here. Okay, so 1.18. So the nice thing about using your calculator, on your Z chart, you've got to find one area, find another area, and you have to subtract the two of them to find this area in between, because that's what you're looking at. But if you use the calculator and it asks you for the lower bound and it asks you for the upper bound, then you can just put in those numbers and your calculator will spit it back to you at 0.6199, so forth. And so the answer to this problem will be about 62%. I didn't want a parentheses. 62%. Okay. Again, if you were using the tables, you would have to find the number that goes with the lower, find the number that goes with the upper, and then you would subtract the two to get that middle number. Okay? All right, last example that we have. Again, finding intervals, a real world example. Okay, as part of a medical study, a researcher selects a study group with a mean of 190 pounds and a standard deviation of 12 pounds. Assume the weights are normally distributed. Okay, if the study will mainly focus on participants whose weights are in the middle 80% of the data, what range of weights will this include? So, again, I like to sketch it so I have some idea of what's going on here. All right, so in the middle, I'm looking for the middle 80%, which means that I'm going to go somewhere. I got to go, let's go with half here. So I've got to go 0.4 on both sides. Okay, and that is the area under the curve, however far that is. So that means what's left, actually let me, you can go ahead and write your z-values. That's my standard deviation, but this is not the z-value, so this is the kind where we go backwards, okay? But if I need 0.4, then that means that what's left is going to be 0.5 minus 0.4, because remember all the way to here is 0.5, right? That's 0.5. So if this is zero point 0.4, then this part has to be 0.1 because I subtracted the two numbers. So this time you're going to do, on your calculator, you're going to, when you go into your probability, your distribution menu, you're going to use number 3 because you're going backwards. And when you put in the area, you're going to put in 0.1 and your calculator is going to spit back at you a number that would round to, or the table would give you negative 1.28. The scale's not off, it would be a little bit more. Okay, and then we would have on the other side would be 1.28 because we are in the middle. We're looking for that middle 80%. Okay, but that is the z value and they want to know what the weights are. So that means that I'm going to use that formula. Negative 1.28 is my z value. What is the data value? So x minus the mean of 190 over the standard deviation of 12. Okay, again, multiply by 12, so I'm going to have negative 15.38 equals x minus 190. And so x will equal 174.62. Okay, I'm going to do the same thing with plus. So I'm going to have 1.28 equals x minus 190 over 12. Solve it the same way, and you're going to get x equals 205.38. So the question asks, um, who's what range of weights will this include? It's going to include the ones that go from 174.6 pounds to 205.4 pounds. Okay, and then the last one says we want to those people whose weights fall in the outside 5%, and we're going to contact those. So we're going to again draw our curve, and I'm going 0, and I need the outside 5%. So hopefully you know by now we got to divide that number by 2, okay? And so the outside 5%, half of 5% is 2.5, so that's 0.025 on both sides, 0.025. All right, so you put that in your calculator and it's going to spit back at you negative 1.96. So surely you can see that's going to be close to 2 standard deviations, right? Right before it. And again, we're going to set it equal. Negative 1.96 is our data value minus the mean over the standard deviation. Multiply both sides by 12, and that's going to give me negative 23.52 equals x minus 190. So x equals 116, nope, 166.48. Okay, and you'll do the same thing with the positive value, because that's what this one is going to be. Go through the steps to solve it, and you will get that x equals 213.52. And just like we talked last time, they wanted the outside, so this time we're talking about these values. So when I write my answer, then it's going to be those values that are less than 166.5 pounds, or those that are greater than 213.5 pounds. All right, that sums up. You've got the steps to use your calculator. You have a chart that will be on my calendar. If you have any questions with either one, ask somebody in class or come see me. We will have a lesson check the next time I see you.